So welcome everyone. Thank you for taking time to join today's webinar. My name is Gavin Dawson. I'm the client partner at Sparity. So Sparity is a technology consulting and product firm based out of Atlanta, Georgia. And my role with Sparity is to help our clients solving the challenges by providing the right solutions to them. So today, like everyone, even I'm eager to know why 90% of the data science engagements fail. So to address this, I would like to introduce you to Jay Bhadravu, our head of data science. Jay is alumnus of Indian School of Business, popularly known as ISB. It is one of the third top universities in the country, and Jay has over 12 years of experience across data science, management consulting, business analysis, and working with some of the Fortune 500 companies. Currently, Jay leads the Data Science Center of Excellence at Sparity. So before we get started, wanted to set the expectations of today's meetings in terms of how we should go ahead with the Q&A session and when we'll be taking it. So if you have any questions during the presentation, please type them into the Q&A box below in your Zoom control panel, and we will address them at the end. Now, without any further delay, we'll get started. Over to you, Jay.
Thanks, Gavin. Thank you so much for the introduction. So guys, we'll get started with the webinar, and I'd like to set some context before that. While the whole world today stands in solidarity and fights the deadly COVID-19 virus, we thought this webinar would actually act as a very good tool to spread the positivity and break away from monotony. Okay, so for doing this, we would like to share certain success stories of organizations which have implemented, or rather you can say misimplemented, data science projects, learned from their mistakes, and emerged out victorious. And while Sparity acted as a strategic partner throughout, guiding them to accomplish this task. So we also intend to share certain frameworks and industry best practices that we at Sparity have gathered while working with small, medium, and large scale enterprises. So that's the context behind today's webinar, everyone. So let's get started with the webinar now. So first, we'd like to discuss about some of the common myths and misconceptions that exist in the industry currently. So the first one talks about data science initiative as a initiative from CTO's office. So that's one of the biggest misconceptions that are there in the industry right now. Most of the people think that data science is a technology subject, but if you look at data science, it's an amalgamation of three different skills: business or domain understanding, mathematics, statistics, and technology. So you can find data science at the center of all these three different skills that we have talked about. So ideally, data science, you can call it as a business initiative, which is rather driven by a lot of businesses to improve their business outcome by leveraging applied sciences and technology. So that's the fact behind what data science is all about. And another myth that surrounds data science is about the expectations. Okay, so there are two different sets of people when it comes to expectations regarding data science. So the first set talks about data science as a bubble, or they feel that data science is hyped. So this is a set that have under expectations towards data science. And there is another set of the people who think data science is just a magic wand. Okay, so innovations typically happen very quickly, and return on investments also are realized very quickly. So that's another big myth. And the fact that we observe is ROI of any of the data science implementations, for that matter, typically depends on what use case that particular organization is implementing. And as some of the use cases have a very long horizon, some of the use cases also do have a shorter return on investment horizon. So it completely depends on what kind of engagement that an organization is looking at. And the third myth that I'd want to talk about is some of the organizations still feel that data is kind of a byproduct of their business as usual activity, BAU activity. And that needs to be stored for typically transactional and regulatory purposes. But most of the successful organizations, they really treat data as a strategic asset, and they also feel that it gives them a significant competitive advantage. So if an organization needs to look at data, they need to look at it from a strategic standpoint rather than just looking at it from business as usual standpoint. So that's another myth versus fact that we wanted to talk about. Okay, so now we'll go ahead and look at how some of the organizations have actually failed implementing data science projects and how did they actually learn from it and how we at Sparity have helped them to do so. So for that, we have constructed this 4-piece of data science implementation framework. So we have process, platform, project, and people. So we'd like to go through this webinar through this particular framework by looking at the challenges through this particular framework. So let me go ahead and talk about each of these in much more detail. So first, let's start with process. Process typically talks about how does an organization approach data science engagements and how do they actually want to extract return on investments from it, and what is the current process that they have in the organization that support this kind of a initiative. And then it comes to platform, where an organization needs to understand what kind of technology stack it has to use so that it can implement certain data science use cases within the organization. Then we have project, where it all depends on how do you execute a project end to end in the data science spectrum, and how do you put it into live production environment. So what are the challenges that you find while implementing these projects? And last but not the least, we'd like to talk about people, where we would touch upon change management. Okay, now that the data science cases have been implemented and use cases have been implemented and they have been pushed to the live environment, so how do you manage the change within an organization? Because now after implementation of these data science use cases or AI use cases, the way businesses operate on day-to-day basis might change in certain situations. So that's where how do you deal with change management is something that we are going to talk about when it comes to people. Now I'll pick up the first P. So the first P talks about the process. Now this is where the organizations try to have two different approaches. Some of the organizations pick up a tactical approach, where that's more a use case driven approach, where an organization already has a certain use case in mind and they'd want to implement that particular use case. So that's what is a tactical approach. And when it comes to a strategic approach, that is where an organization doesn't target any one particular use case, but it has a more holistic, it follows a more holistic approach in order to implement the entire data science roadmap that they have come up with. So these are two different approaches the organizations take. Okay, so let me explain this with an example or a case study. So this particular case in question is for a healthcare client. So this is a unicorn startup which was based out of Singapore. This particular startup created an app that linked patients and doctors together while booking appointments for the patients. So the client actually had a procedure already in place that matches doctors with the patients. That was a kind of a rule driven approach. Now they wanted to break away from this, and they wanted to create a much more refined way of approaching this problem by leveraging machine learning. So that's where Sparity as a partner stepped in. And initially when the project got kickstarted, so we started off with this tactical approach first because we wanted to address this particular use case. And to start off this engagement, we were looking at, okay, so what's the data that the organization has? So we start off by looking at the patient and doctor halos. Okay, now what's a halo? Halo is nothing but a digital footprint that entity leaves behind while interacting with the application. So there is a patient halo and a doctor halo. Patient halo could be anything ranging from demographics, what kind of diseases this patient has searched for, what kind of doctors this patient has actually booked appointment for. So those are some of the examples of halos of patients. And for doctors, the halos could be something like, so what's the demographic of the doctor? What's the kind of specialization of the doctor? How many patients has he handled? Okay, how many hours of patient time has he spent? So all of these things are doctor halos. Now, once we have gathered both patient and doctor halos, we go ahead and check how to match both of these entities together through a machine learning process. So that was the approach that we wanted to take. But as we started dealing with this kind of a project, we understood that there were a lot of challenges with respect to data accuracy, consistency, and also availability. So we found this out while we did the data due diligence, and that was always almost halfway through the project when we realized that, okay, so there are a lot of inconsistencies in the data. So this actually impacted the overall solution, and this resulted in an ineffective solution that was being delivered to the client. So again, we restructured this entire engagement. So we approached the client and we told them that maybe this might not be the right kind of an approach. We'll have to take an alternative strategy where we go ahead and look at their overall roadmap. We understand their current state of data science maturity. Then from that, we create a clear roadmap with respect to where is the organization right now from the data science implementation perspective, and where it can actually head towards in the next given future, what kind of use cases can be implemented. So when we have given this kind of a roadmap, we have also created a center of excellence for the client, where the team that was responsible for implementing these use cases used to evolve these projects one by one, and in a more refined manner rolled out these engagements into the production environment. So this resulted in a huge success rate. So one thing that I can talk about from this use case is, instead of following a tactical approach, every organization should actually look at a more strategic approach. They need to understand what's their current data science maturity, and based on that, they need to pick up the use cases and implement them. So for dealing with these type of scenarios, we have come up with a kind of a maturity model, data science maturity model, where we get into an engagement with an organization. We look at their current data science maturity. We evaluate this through a defined set of questionnaire. And once we get to know the data science maturity of a firm, then we place them in either of these quadrants. So there are 3 different phases here. Phase 1 talks about learning and getting ready phase. So this is a phase where most of the organizations in their inception of their data science journey are. Then we have phase 2, where the organizations are ready to implement certain type of more complex use cases. And the phase 3 is the optimization phase, where they actually get to be a market leader and become a really data science driven enterprise. So this entire journey has to be taken by an organization to successfully witness data science project growth and to move towards more data centric approach within most of their engagements. So in the learn phase, organizations typically do use case identification. They understand what kind of use cases can we actually target, and they do this by first understanding business process mapping. So first they look at the overall data that exists within the organization. They look at the process, and then they do something called as a business process mapping, where every process element is linked to a data element. And this kind of a mapping helps the organization to understand what's the data that they do have in store. Based on this, the organization can go ahead and create a use case. Now at this stage, they also identify the various risks associated with the data and sketch the overall data strategy. So these days, most of the organizations have their data stored in various silos. So how can we create a monolithic data environment where we can pull the data from various sources, integrate it, and then use it for data science projects? So that's something that most of the organizations need to do in the inception stage. Then we move to the get ready phase, where once you have identified some basic data structures within your organization, then you go ahead and look at how do you perform exploratory analysis? So this is where you're going to hook up your databases to more advanced tools like Tableau, ClickView. These are visualization tools where you're going to try and look at exploratory analysis, and you're going to understand what various trends that are presented by your data. So now this is the stage where you also define an operating model, where you try to understand how to create an analytics office. So this analytics office talks more in terms of how do we run data science engagements on day-to-day basis. So who are the various players involved and what is the process they need to follow in order to execute the data science engagements. So that's what they're going to do in the get ready phase. And then you can also implement certain ad hoc reporting requirements in this phase, and also create certain proof of concepts for the use cases that were actually discussed in the earlier phase, that is in the learning phase. So learning phase is just a whole list of use cases that you actually come up with, but you're not yet sure which of these use cases can actually be implemented. So for that, you go ahead and create certain POCs or proof of concepts in the next stage, that is the get ready stage. Then we finally move to the third stage, that is the implement stage, where we are going to try and integrate online and offline data sources. So some of the organizations have online data and offline data. When I say offline data, it talks more in terms of if there is a business which has both online business and offline business. Let's take an example of an apparel business. So let's say there is a player who sells their apparel online and also sells their apparel offline through a brick and mortar store. So how can we integrate these two disparate data points and come up with a holistic data view? So that's what is online offline integration. And also, how can we do certain pattern analysis and pattern discovery based on the use cases that we have identified in the learn phase? Then this is where some of the use cases that had matured into proof of concept stage now get to see how these can be actually built into solutions. So this is the step where we start building solutions from the proof of concepts that we have created in the earlier stage. And this is the right stage at which attribution analysis also needs to happen. So what is attribution analysis? Attribution analysis is nothing but how can we actually come up with the return on investment on the projects that we have just put into the production. So how can we attribute success factors to these projects? So that needs to be discussed at this phase. And also we need to perform business outcome analysis. I'll talk about business outcome analysis as a project execution strategy in the subsequent slides. So business outcome analysis is a framework through which you implement data science engagements. So more on this later. So that's the implement phase. Okay, now we move to the final phase, that is the optimize phase, where an organization would be ready to implement deep data mining activities where they can dive deeper into the data and understand the more finer use cases, and also come up with machine learning algorithms and deep learning algorithms that can actually support the use cases that were earlier identified. Now, this is the best time at which an organization might also want to rethink on their business strategy altogether, because right now at this juncture, an organization would have a completely different view about the business that they are running, because they have a very good understanding about the data that they hold. So that can also be done at this stage. And finally, an organization can become a self-sufficient data innovation enterprise and a market leader when it has grip on the data that it has and the use cases that can be implemented. So that's the entire framework that can be looked upon while implementing data science projects. So this is a framework that we wanted to share with you from the process perspective. So most of the organizations make a mistake of jumping the gun and directly getting into implement or optimize phase. So what we recommend is, first, they need to understand where they currently are in which phase, and according to that, they need to move ahead in their data science journey. Okay, so the next P after process is our platform. This is our second P, where we are going to talk more in terms of the tech stack. So this is a juncture at which an organization needs to understand what kind of tech stack needs to be implemented for data science projects within itself. So that is where it gets into a crossroads where it has to decide whether R, Python, SAS, what kind of software we need to use, and also what kind of hardware implementation needs to be done. So should I have an on-premise server? Should I move to GCP, Google Cloud, or AWS, Amazon Cloud, or Azure? So this is a choice that an organization has to make at this point of time. And also what type of compute. Okay, so how many GPUs, what kind of CPUs that we need to use. Okay, so what's the kind of RAM that needs to get into it. So all these considerations needs to be done while we are at this particular phase. So what we typically recommend is, instead of picking up a blueprint or a standard tool stack from this, an organization should moreover look at technology sandboxing and quick prototyping. That is, there is no one size fits all kind of a solution when it comes to data science implementations. So that is where an organization needs to look at a use case that they're trying to implement. And based on that particular use case, they need to understand which technology stack and which hardware stack fits it right. So our learning here from the platform stage is, do not create a blueprint or a standard environment for implementing data science projects. So the tech stack completely depends upon the use case. And for that, you need to quickly create technology sandboxes and do quick prototyping and check whether this technology suits the use case that we are trying to implement. So to illustrate this learning, I'd like to talk about an example here through a case study. So this case study is also in the healthcare segment. So this particular player, the client, was in the IoT space, healthcare IoT, and this is an Indian client. This client created an app, a telemedicine app that connects remote patients with the caregivers. Now, the project background was, the client wanted to implement an algorithm that would leverage deep learning in order to understand if there are arrhythmias in a given ECG pattern. So every ECG generates PQRST fluctuations, and based on those fluctuations, the client wanted to automatically alert the caregiver on arrhythmia events. So that was a project background. So while this project was implemented earlier, so client already tried their hand at implementing this engagement earlier with their own team. So the solution that the client has created was more asynchronous, and they've used a technology stack called as FlashCap and OpenCV, simply because they already had certain other engagements that they have, other projects that they have delivered in this through the same technology. So they were more comfortable with it. Their team was more comfortable with it. So they went ahead and they implemented this particular solution. But this resulted in a significant overhead on the inference server. Okay, so while they have trained their models, and when they have created this particular tech stack for inference, that is, when the inference was being done, there was a 8 to 9 minutes latency. So that was not acceptable in this particular use case, because the tech stack simply doesn't support real-time alerts. So that is where we have re-engineered their current tech stack and suggested an alternate tech stack to be used. That is, we wanted this entire use case to be implemented on GCP, TensorFlow and TensorServe kind of a tech stack, where TensorFlow and TensorServe, since they are native to Google Cloud, so the latency could be further reduced by implementing this through TPUs, tensor processing units. So the latency was reduced almost up till 40 to 50 seconds. So this is a classic example where incorrect tech stack can actually prove to be catastrophic for the entire engagement. So the learning from this case study is, if an organization wants to implement a use case, better not to follow a blueprint or a standard tech stack. It would be always advisable to look at every use case in its own merit and come up with a tech stack that supports it. Okay, so now we are done with process and platform. Now we move ahead with the project. A lot of organizations again get into a spiral of implementing data science engagements through a standard SDLC waterfall model or agile process. But again, the problem here is data science doesn't work as any other IT project or any other software build. We'll look at this through an example. And the third kind of an approach is the business outcome analysis. That is a goal-based approach. So we will look at business outcome analysis. I've referred to business outcome analysis in the earlier slide as well, while we were talking about the data science maturity. So now I'm going to talk more in terms of business outcome analysis and how it will be implemented. But before that, let's again go through a case study. So this case study is in the context of a company that deals with the legal work. So the client that we are talking about is a company that does legal commentary and comes up with research in this area. So now the project background was there is a lot of time that is spent by legal assistants in order to go through legal documents and understand what are the various cases that are cited, and understand the case IDs, case numbers, and link the case IDs and case numbers to the case names. So this is a monotonous process that they follow every day, and this is where a lot of manual work is being put by the organization. So they wanted us to build a machine learning solution that automatically identifies all the case references wherever they're present in the given text, and it links it to the appropriate case IDs. So that was the project background. And before we stepped in, the client went ahead with an SDLC factory model for the implementation of the project, where the client has engaged a business analyst, a Python developer, an ML engineer, and a QA team. So this is a factory model where every person involved doesn't get to know what's happening or what's the entire context that's happening in the other person's portfolio. So that's where a business analyst, a Python developer, a ML engineer, and a QA team has been roped into this assignment, where a BA's responsibility was to play a role of a domain expert, gather all the requirements, pass on these requirements to the ML engineer, who would look at the case on hand and understand which kind of mathematical model is much more appropriate for accomplishing this task. And once he decides on that, a Python developer actually builds the solution and passes it on to the QA team for the testing. So now when the team started working on this, the kind of accuracy levels that the overall solution has reached was not close to satisfactory. So that's the reason, again, the client has approached Sparity, and we have redone the entire project through a different approach. We followed something called as a business outcome analysis, where instead of deploying multiple resources from various skill sets, we have deployed 3 data scientists. Data scientists, again, as I've indicated in the first slide, data scientist is a person who has three different skills: technology, business, and mathematical understanding. So he's a jack of all these 3 trades. So that is where we have deployed 3 data scientists who are working on the business outcome analysis model to implement this engagement, and we have successfully delivered this engagement to the client, and we have met the business outcomes that were agreed upon while we started off with this engagement. Okay, so what is business outcome analysis and how do we implement it? So let's talk about that framework now. Business outcome analysis is a framework through which data science engagements can be put into the production environment. So the first stage, we call it as discover stage, where we gather as much information as possible from the customer, from the client, end users, and we do this through an engagement level review and understand what are the various outcomes or business outcomes that a client wants to address. So again, coming back to what is a business outcome? Business outcome is a measurable outcome that can actually talk about health of an organization. So in this case, the business outcomes that we are referring to are more in terms of improving the productivity. So what's the current productivity? That is, we understand the current productivity from the measurable standpoint, and what is the outcome that we want to get to. So that kind of an outcome is what is arrived at this particular juncture. And we also try to analyze the challenges that we are facing right now to meet that outcome, and what are the kind of performance gaps that we have right now. And we understand these gaps while we compare the current stage of the outcome with the industry standard or a benchmark. So once we get to understand this, we get to a next phase where we do solution brainstorming. Okay, we know where are we currently. We also know where do we want to get in after implementing this project. So to fill this kind of a gap, what's the kind of solution that needs to be that needs to be followed. So that's something that we do in the solution brainstorming phase. So that is where data scientists come up with an approach for meeting the business outcomes. So now the project outcomes are now linked to the business outcomes that were discussed earlier. So in the case of the legal assistants, the business outcome that we are talking about here is to improve the productivity. Now, once we establish those project objectives and link them back to the business outcomes, then we come up with implementation plans. Okay, how are we going to implement this project? So are we going to go big bang and release this project throughout all the geographies, throughout all the business units, or how are we going to go ahead with a staggered approach? So that is something that actually we can look at when it comes to this particular phase. And then we also set certain operational tolerances. That is, okay, now that we understand that these are the objectives that we have set, so how can the project have tolerances? How can it accept certain level of deviations from the objectives that were set? So those are also understood at this juncture. And then next phase is the implementation phase, where we finally get to implement the solution. But again, according to the implementation plan, if we want to do it in a staggered manner, we pick up certain eligible business units or certain candidate geographies, and we implement the solution there, audit the solution, identify if the gaps were met as discussed in the last stage. And once this is satisfactory, then we institutionalize this solution across all the geographies, across all the business units, and we continuously keep monitoring and tracking the performance of these models and report the effectiveness of the models implemented to the business and tied back to the business outcomes that were derived. So this entire cycle is called as a business outcome analysis. Okay, so now we come to the last P. So we are done with process, platform, project, and this is where we deal with people. So this is where we have two different strategies that we recommend for implementing data science projects. One is a push strategy and other one is a pull strategy. So in the case of a push strategy, I'll again quickly talk about one of the case studies. So we were implementing a project for a telecom client. So this is where we wanted to reduce the overall ticket volume that a support team receives. So in the interest of time, I'll not get too deep into this particular engagement, but I'll just talk more in terms of what was the problem that we have faced. Okay, the solution that we have built was a really best in class solution, and we wanted to implement it so that there is a reduction in the overall ticket volume. And the mistake that we have done at that point of time was pitching this at a wrong level. We pitched it at the line manager level, where we talked about how this project can actually reduce that overall ticket volume. That means that because of this kind of a project, there could be a lot of people in his particular team who could actually lose their significance in that particular engagement. So for those reasons, the line managers did not want this project to fly. So we have understood that we have pitched this solution at a wrong level. So that is where we wanted to go ahead and talk to the operations in charge, the COO and his team, who were really impressed with this project. And because that results in significant cost cutting, they went ahead and pushed upon the next line of managers to implement this solution. So this is a learning which we had from this project, where we need to pitch the solutions at the right level, at the right business stakeholder level. Another one was a pull strategy, where we don't thrust upon the solution to be used by the end users. So in this case, so we were working with a banking client. So in this example, we were trying to build a model that identifies the potential target clients that a relationship manager needs to pursue in order to fulfill his lead conversion task. So this is where we created a model that would ideally pick up the candidates that a relationship manager would pursue. Earlier on, relationship manager would pick the candidates himself. Now the model is doing it for him. So for those reasons, the relationship managers were reluctant to use this AI-based model because their relevance in the organization would come down. And for those reasons, they rejected taking up this kind of a tool that actually makes their work easier. So the way we have dealt with this kind of an engagement is we went ahead and created this tool as an optional add-in into their existing CRM. So if a relationship manager looks at his CRM, he has all the potential target clients that he can handle. And if he sets up this as an add-in, against every client, probability of conversion is displayed. So this was made as an optional add-in. So all the relationship managers were completely given a free hand whether to use this or not. So as it happens in any given organization, there is a bell curve that is followed. So in the natural selection of a bell curve, there are people who fall in the last category. Let's say for performance one, performance rating one relationship managers are the best in the organizations. Performance rating four are the last players when it comes to the performance level. So all the people who are in third and fourth league started using this tool so that they can actually improve their performance. And through this, they've successfully moved to the next level and posed a competition to people who are there in the second level. And since the tool was very effective, and the second level relationship managers were getting enough stiff competition from the level 3 and level 4 people, so they started using the tool. As level 2 also started adopting and giving a push to the level 1 folks, so level 1 folks also ultimately had no choice than using this tool to augment their current capabilities. So that's a kind of a pull strategy. So in the push, we pitched it at the right level and thrust it upon all the end users. In the pull strategy, we give this as an option and see how the user base actually picks up this project naturally. So these can be implemented based on the use case that we are trying to accomplish. Okay, so those were the 4 P's of the framework, everyone. So now let's talk about the implementation time frame. When does an organization needs to implement each of these P's? So whenever you are starting off your data science journey, you can split that into prerequisite phase, and you can also do certain activities in parallel as you are getting ahead with the data science implementations. So if you look at the x-axis, it talks about the prerequisite and in parallel phases, and y-axis talks about the criticality, how critical addressing each of these problems could be. So in the initial stages, as a prerequisite, most of the organizations should check their process maturity and also get an executive buy-in, because data science projects always work in a top-down approach, so that there is a push from the executive level management, and that is when the data science engagements really get to the fruition. So that needs to be first done, executive adoption, and then budget limitation needs to be sorted out. Okay, so you need to earmark a budget for this. So most of the organizations earlier used to have discretionary spends put aside for data science implementations, but right now most of the successful organizations are treating data science as a much more strategic objective, and that's the reason they are putting aside strategic spends, not discretionary spends for data science implementations. So that's where you need to allocate certain budgets. And once you are clear with this, in the next stage, you need to look at regulatory landscape. So the way we have defined this entire graph is both in terms of the things that you need to handle internally and the things that are external to your organization but still affect your data science journey. Okay, so then next phase, you have data due diligence that needs to be performed, and problem identification, use case identification. Then followed by ROI attribution. How do you attribute success factors to your project? Followed by how do you competitively position yourself in the market when it comes to the machine learning or AI implementations? Then we talk about the technology adaptation, the tech stack that we have talked about. Then you'll have to go ahead and understand how do you procure talent. And then finally, how do you eliminate vendor dependency? So this, in a chronological order, you need to address so that your organization can move ahead of all these challenges and see successful data science implementations. Now, there are various COE implementation approaches. So first is a hub and spoke model. So as an organization starts off while implementing a center of excellence, in the initial stage, it is recommended they go ahead with a centralized data science team, where all the different players or all the different departments, marketing, sales, operations, they come to the centralized data science team with their business problems and get data science solutions. At a later point of time, as the team gathers more maturity, you can move into a satellite model where every department has its own data science team, which carries heavy subject matter expertise in that regard, so that you can implement much more serious use cases, much more refined approaches towards the solutions. So that's the satellite model that organization can move to once they have gathered some maturity with respect to data science implementations. Okay, I'll also quickly talk about the data science value chain. So now that the COE has been set up within an organization, so if you understand the chronology of events, we have discussed till now what are the 4 P's the challenges that can be addressed through these 4Ps. We have talked about various frameworks while covering these 4Ps, and then we move to how do you address these challenges, at what stage in your data science maturity level do you address these challenges as an organization. And then we went ahead and looked at how can a center of excellence be more effective in terms of solving your data science problems. We looked at a centralized approach as well as satellite approach. Okay, now that the COE has been put together, how can we create a data science value chain, a target operating model that can be implemented to solve data science problems? So this is where we start off with problem definition phase, where we understand, again, you have to understand that whatever we are referring to right now is in the context of a center of excellence. Now, this is an approach a center of excellence should follow. So first step is problem identification. So this is a phase where the data scientist team as part of center of excellence should engage with the stakeholders, business stakeholders, conduct a lot of managed innovation workshops, and try to understand what kind of business problems exist within the organization. So once they have come up with a list of candidate problems, they need to go ahead and look at categorization of these problems, whether these problems fall under simple dashboarding or visualization problems, or there is a predictive model that needs to be built, a prescriptive model that needs to be built. These are the kind of use cases that come in for machine learning purposes. So once we have categorized the problem, then we have to go ahead and look at how do you prioritize. So the COE should prioritize the problems based on the revenue impact, feasibility, complexity, urgency. These are the parameters that the COE needs to consider in order to prioritize the use cases that were actually discussed. Okay, now after prioritization comes picking up the actual use cases and starting off with the solutions. So for that, we need to understand the data first. So for those reasons, we need to understand the scope of the data, what are the various data sources involved, and how to look at the data quality. Okay, so when I say quality terms, it is more in terms of how do you assess the completeness, correctness in the data, and also take care of data governance to ensure right people are getting their hands on the data. So once we know what kind of data exists within the organization, then we can also now target solving the problems that were identified in the earlier segment by leveraging the data that has been identified in the second phase. And in the third step, that is where the insight generation happens. This is where model selection needs to be done. Based on whatever use case that was identified, an appropriate mathematical model or a data science model has to be selected, trained, and implemented. So that's the next phase at which the model has been trained and put into the production environment. And if necessary, the model outcomes needs to be reported, and dashboards, the model outcomes can be integrated with the dashboard so that the end users can actually look at it. And finally, once this project is live and kicking in the production environment, the next stage is insight distribution, where a COE, a data science COE, should be ready to analytically talk about the story behind this entire implementation and report it to the business stakeholders. So whoever is responsible for this particular use case outcomes, so that is where a team needs to put together a story in terms of how did they start, what did they accomplish, and put it forward to the stakeholders, and also deal with the change management as we have discussed in the people phase. And finally, we'll also have to attribute the project outcomes. So whatever were discussed and approved as project outcomes earlier, so have they been met? And we need to understand what kind of leading indicators and lagging indicators these project outcomes result in. Leading indicators are the ones which come first, like conversion rates, acquisition rates. Lagging indicators come as a consequence of the leading indicators, like improvement in the revenue, decrease in the cost, improvement in the profit. So this is an end-to-end data science value chain implementation that needs to be taken up by organizations. Okay, guys, so that brings me to the end of these frameworks and the way organizations needs to approach data science engagements. So this is the learning that we wanted to convey to everyone so that they can also make most of their data science engagements. Now, let me also talk about Sparity and magic equation. So Gavin has already introduced all of you to Sparity. So Sparity has a decades-long experience in providing IT solutions to small, medium, and large-scale enterprises. And Magic Equation is a brand that we are launching right now. So we felt that while we are implementing data science engagements from Sparity, we always felt there is a need for coming up with a boutique data science and analytics consulting firm, which is much more focused on data science and AI engagements. So that's the reason we have now come up with Magic Equation. That we are going to go live with Magic Equation through this webinar right now. So our vision behind setting up Magic Equation as a data science and AI consulting firm is to solve that complex data science problem that every organization has. And we firmly believe that every organization has a secret magic equation for success that is waiting to be solved. So that's the reason we have set up Magic Equation. And our mission is to cater to data science and AI needs of organizations, irrespective of their scale, small, medium, or large scale enterprises. And we firmly believe in democratization of machine learning, data science, and AI skills. So for those reasons, we have instituted Magic Equation. And these are our service offerings as part of Magic Equation. We help organizations to build center of excellences. And while we do that, we also try to make sure the center of excellence that has been built for an organization will scale up to the right kind of opportunities at the right kind of time. And also we wanted to deal with end-to-end data science implementations. So for that, we have created 4 pillars of service offerings. That is essential components, which are some of the basic necessities of an organization to implement data science engagements, like how to create data science architectures, reference solutions, how to come up with visualizations, dashboards, advanced BI tools, and also how to come up with data assurance standards, how to meet data assurance standards within a given organization. And also we help organizations to build use cases. And we also come up with annotation services. I'll talk about it from our product perspective in the later slides. But annotation is a process through which we convert data into the machine learning format. So that is something that we also provide. And organizational components are much to do with how to implement these projects. And competency development is to do with setting up the center of excellence within an organization. So providing R&D services, and we have talked about the technology sandboxes, how to create the technology sandboxes for various use cases, and also how to do the attribution analysis and any technology and domain related consulting, right? So that we put it as part of the competency development. And finally, we have peripheral components that are kind of supporting services that we provide to the COE in terms of training, certifications, and business user onboarding and knowledge management. So these are the holistic list of services that Magic Equation, our boutique data science and analytics firm, offers to the clients. And we also have our own training brand, Data Science Authority. So we also train resources on data science and machine learning. And we also recruit the necessary resources from Data Science Authority. Data Science Authority is a training organization that is owned by Sparity, where we train people on data science and AI through experiential learning process. And we have offline centers back in India, as well as we provide online training. And if any of the organization needs recruitment services, we also provide it through DSA. Now coming to our products of Magic Equation, one of the product that we have for Magic Equation is Expert.ai, which is a labeling service or annotation service, as we have discussed earlier. So annotation is a process of converting data into machine learning ready format. So we have a platform that crowdsources this labeling activity for the clients. And for people who don't know what labeling is a process where, let's say, if you want to identify that a particular image is an image of a cat, then you need to feed a lot of images which are labeled as cat to the machine so that it can understand the attributes of a cat. So that's called as a labeling process. So now we have built this platform to outsource this labeling process. So that's a crowdsourced platform that we have that's called as Expert.ai. And we also have ZeroML, which is our zero machine learning platform, where a client need not have any idea about machine learning, no prerequisites of cloud knowledge. He can get onto the platform and experiment with various models that we have already pre-trained, and also can train their own models without any machine learning knowledge. So this is kind of an AutoML platform that we have come up with from our end. So this is a zero machine learning platform that we have created for the clients. So now to put everything together and to talk about the ecosystem that we have built. So in a nutshell, we are going to help clients achieve their data science project implementations by understanding their business domain. We also conduct your data science maturity assessment. We understand what kind of use cases that you have and what you intend to take up, and we also help you to prioritize them. We create a detailed data science journey map or implementation map for you. Then we can also understand what are the various risks that your organization can actually face with respect to regulatory frameworks or with respect to the data lapses. And we can also help you to figure out your target operating model and execute all the use cases that were identified in the journey map. So to do this, our services start from consulting, from Magic Equation, where we get into a consulting phase to understand your requirement and give you consultative services in the beginning. Then if you need training and recruitment, we do it through Data Science Authority, that is in the team building. And for the project execution, we do it through Magic Equation, which brings in data science and AI expertise through a pool of data science and AI engineers. And also Sparity comes in whenever you need to develop an application and we need technology inputs, then Sparity comes in as a technology partner. So this brings us to a bird's eye view of the data science services that we are offered from our ecosystem. Okay, guys, so that's all I had to share with you all today. And for further inquiries on various opportunities that you want to share with us, you can get in touch with Gavin Dawson, our client partner, and you have his details on the screen right now. Okay, so thanks for listening out. So that's something that I'd want to end this presentation with, and maybe we can open the floor for Q&A.
Yeah, thank you, Jay. We'll go ahead and take some time for questions for now. Just as a reminder, please be sure to type your questions into the question box in your panel. So Jay, there are a few questions. Probably we'll take one by one.
Sure.
So the first question is, we have a use case to extract some specific info from huge pile of text documents. Have you worked on similar use cases earlier?
Yes, we did work with some of the use cases in this lines. So I've also mentioned one of such use case in the case studies that was discussed in this presentation. We've talked about extracting case IDs and case names from huge pile of legal documents. So that exactly is what is your use case also talking about. So yes, in a nutshell, given a huge pile of text documents, we can definitely extract that custom entities that you'd want to track.
Okay. There's one more question from John Smith. He has posted me personally. So we have created one of our sandboxes on GCP, but
Okay.
we are not happy with the features of the platform.
Okay.
How much of an effort it will be to move to AWS now?
So it depends on the use case that you're trying to build. If you feel that GCP is not working out well, then you need to first address the problem of why is it not working out. So there might be a problem with respect to the current architecture, technology architecture within GCP, because talking about GCP versus, let's say, another cloud service provider like AWS. So moving could really be a great deal if you're already halfway through the use case or you've already started building the solution. But if you're in the inception stage and if you're not comfortable with the platform, or if you don't see value in it, then yes, definitely you can move to some other cloud service provider. That again depends on which stage of data science project implementation that you are in right now, and what's the kind of problem that you're facing. Is it really a problem with the cloud platform, or is it the problem with the tech stack or the current current platform infrastructure that you have set up for this engagement? So that needs to be evaluated first, and then you can plan to move to another cloud service provider.
Okay, I hope this answers your question, John Smith. So we have one more question from Pradeep. What is your team size and capabilities with respect to deep learning based implementations?
See, our team size, we have 8 data scientists. When I say data scientists, these guys are trained on all the 3 aspects that we talked about: domain, that is business, technology, and mathematical skills, all the 3 skills. So who work with us on various engagements. And also we can quickly ramp up our resources from Data Science Authority. So we maintain a core flexi team. So if we need more resources, we take it in from the recruitment partner Data Science Authority, and we can quickly scale up. And on contractual basis, we can definitely go ahead and implement the solutions. So from deep learning perspective, we do have expertise in all the machine learning frameworks, starting from native Python frameworks like scikit-learn, and also some of the advanced frameworks like Theano, PyTorch, TensorFlow, Keras. So we have expertise with respect to all the deep learning frameworks that are there in the market right now.
Okay. Pradeep has one more question. Does your team support data engineering activities as well?
Yes, our team does support data engineering activities, because there are two aspects to any data science project. So one is the data storage and the data retrieval part, and the second activity is the data analysis or the actual data science implementations. So the first half is something that talks about the success of the second half. So if the data, if the data that goes into your project is not well structured, or it's not well organized, then obviously the data science engagements don't see a huge success rate. For those reasons, data science and data engineering are not to be looked at upon as two different aspects. So yes, we do provide data engineering services, and we have a dedicated team that works on these kinds of engagements.
Okay. I hope the question answers your questions, Pradeep. Any other queries do you all have? Jay, it looks like we have covered all our questions. Is there anything else you want to add before I wrap up?
Yeah. So guys, before we wrap up, I'd like to leave you guys with a thought. So for any of the organizations, right? So let it be a small, medium, or large scale organization. So if you want to really excel and be a market leader or create a competitive advantage for yourselves, so there are no two ways about it. You definitely need to go ahead and create a data centric approach for your strategy. So so that you can be a disruptor within your own industry. So I leave you guys with that note, and I wish you well. And that's it from my end, guys. Thank you so much for being an amazing audience. Thanks for sparing time and listening out.
Great. Thank you, everyone. We appreciate you being here. So I'll get in touch with you quickly with a feedback form, and I would be glad if you could spare a few minutes in sharing your comments or feedback on areas where we need to improvise. So definitely that would help us in moving forward with the next webinar that we are yet to present.